Welcome back to Pocket Rock. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Okay, now we're going to be doing percent with chemistry. So we're going to be looking at 14A, 11, and 12. The one thing that I want to keep telling you over and over, that when you are finding a percent of anything means the part over the total. That's how you find the percent of anything. You take whatever part you're looking at divided by the total, and then you'll get a decimal, and then to turn any decimal into a percent, you always have to multiply it by 100. So anytime you're doing percent, you take the part over the total divided by the total and then times 100. Alright? So in 14A, 11, and 12, they're going to give you this it's not a molecule, it's molecules together. They're going to give you this element or chemistry formula. So I'm probably not saying the exact right words, but okay. So Fe, and that's a lowercase e. So what is what does capital F lowercase e stand for? Anytime you have a chemistry element, yeah, then, and you have two letters, when the second letter is lowercase, that's all one element all together. So Fe stands for iron. And you can go find all this information on your periodic table. So, yeah, so anyways, thank you, Mr. Cameraman, for reminding me.
You're welcome.
So Fe stands for iron. This is a subscript of 2. It's really down here lower. That's a 2, not a Z. So when you have a subscript of 2, what does that tell you? It tells you how you have 2 molecules of that. So O is oxygen. You have 3 of them. So here you have 2 iron and you have 3 oxygen. And what the problem is asking for, what is the percent of iron we have in this total compound? That's the word I'm looking for, in the total compound. So, and then what is the percent of oxygen we have in this compound? So here's how we do this. Because if we want the part of the total, then we need to look at each part, and then we need to look at the total compound. So let's just look at iron. So we are told that we have 2 irons, okay? So the first thing you have to do is go to the periodic table and look at the atomic weight for iron. I'm using the numbers in the Matthew C book. They have rounded them. If you go to the periodic table, you probably will have decimals, okay? So I'm going to be using rounded numbers, just so you know, I'm using rounded numbers for my atomic weight. So if you go to the atomic weight for iron, you're going to see that it's 56, but I have 2 of them. So this subscript tells me I have 2 of them, so I need to multiply that by 2. And then multiplying that by 2, that would be 112. Now if I look at oxygen, the atomic weight for oxygen for 1 oxygen is 16, but I have 3 of them. So I need to multiply that by 3. So that would be 48. So my total atomic weight for this compound would be 160. So you need each individual part. I need the individual weight of the iron, and then I need the individual weight for the oxygen, then I need the total weight of the compound. Now I can find the percent of iron. The percent of iron is going to be the part over the total. Okay, if I'm just looking at iron, then for iron, individually for iron, the amount of iron I have is 112. Over the total weight of the compound is 160. So now, if you divide 112 divided by 160, and for any of you people who are chemistry people who are watching this, if I'm not using the right terminology, I apologize. So if you divide that out, that came out to 0.70, but you can't leave your answer in a decimal because it's asking for a percentage. How do you turn it into a percentage? You multiply it by 100. So the percentage of iron in that compound is 70%. Okay, now we need to find the percentage of oxygen. Okay, for oxygen, we do the part over the total. So oxygen individually in this compound is 48, and then over the total compound is 160. So where did I get these numbers? That's the part, that's just the oxygen over the total. Okay, the part over the total. So then take your 48 divided by 160. Be sure and don't do 160 divided by 48 in your calculator. Do your 48, then divided by 160 first in your calculator, and you get 0.30. Turn that into a percentage by multiplying by 100, and that will be 30%. And guess what? It should be 30% because if you only have iron and oxygen, these two things should add up to 100%. If I have 70% of iron, the rest should be oxygen if that's the only thing that I have left. So if these two things don't add up to 100, you did something wrong because these two elements should add up to be 100% of your compound. Alright, now let's look at 14E, 7 and 8. And I can't even tell you the name of these compounds. Okay, I can tell you what the elements are, but not the compound. C is carbon, H is hydrogen. Okay, so they're asking you for the percent of carbon and the percent of hydrogen in this compound. So we get the individual, so carbon. If you look at your periodic table, and they have one in the back of the book, of your workbook and of the instruction book, or you can go Google it, but the values that I'm using are rounded values. Okay, so carbon is 12, and we only have one of them, so we just multiply by 1, so that's 12. Hydrogen, the atomic weight of hydrogen is 1, and we have 4 of them. We have 4 hydrogens, so you have to multiply that by 4. 1 times 4 is 4. So my total atomic weight, adding these two together, I add, just to remind you, are 16. So to find the percentage of carbon, then we do the part over the total. So we do what I have for carbon, 12, over the total atomic weight, 16. Well, dividing that out came out to, oh yeah, I could have reduced that fraction to 3/4, which would have been 0.75. Multiply that by 100 to turn that into a percentage, and so the amount of carbon that we have is 75%. So we have 75% of carbon. So how much hydrogen should we expect? Well, whatever hydrogen is and carbon have to add up to 100. So we should expect 25% of carbon. So let's just calculate it out and see. It's always good to see if your answers make sense. So now that we know what the answer should be, let's just see, put it on paper and do it. So the percentage of hydrogen is the part over the total. So you take the part, which is 4, over the total atomic weight, 16. Well, 4/16, if you reduce that, that would come out to 1/4, which is 0.25. And then 0.25 times 100, turning it into a percentage, is 25%.